Hello! In this video, we'll talk about making delays and using timers on a microcontroller. So one of the most common things that you need to do when interacting with the real world is to measure time or generate an interval of time. So let's start with a simple way of making delay just by having a loop in a program. So suppose we wanted to delay for a certain number of milliseconds. We could declare an integer I and set it to some value and then count down to 0. So while I minus minus keeps counting, subtracting 1 from I until we get down to 0. If we set the initial value as the number of milliseconds we want to wait times some number of counts per millisecond, and then we calibrate that counts per millisecond with a stopwatch until we count for the desired amount of time, then this will make a loop. So when I did this, I found it needed about 1600 counts for 1 millisecond to go by, or 1.6 million counts per second. So this is a simple program to generate delay. And now we could say flash a light by say making pin 5 an output. Remember, pin 5 is hooked up to the blue LED. And then we have a loop. And in that loop, first we turn pin 5 on, make the LED on, wait for 500 milliseconds, half a second, then turn it off and wait again, and this will blink the LED indefinitely. So the trouble with that delay loop function is it requires calibrating the counts per millisecond. First of all, that's kind of tedious to do by hand. Second, it's inexact. Was it exactly 1600 or maybe it was 1670? I didn't measure accurately enough with my stopwatch to know. And finally, if the compiler changed, let's say it made some better code that ran the loop faster, then the amount of delay would no longer be accurate. So a better way to make delays on a microcontroller are with a peripheral called a timer. Many microcontrollers have a whole bunch of timers. Our particular one has a single 64-bit timer that counts ticks of an external 32.768 kilohertz oscillator. So we can take a look at the manual to see how to access this register. We see that it's in the core local interrupter memory mapped peripheral at an address of 200B FF8. And it's a 64-bit register called mtime. So when we read that register, we get the amount of time measured in these 32 kilohertz ticks since the system started. So let's declare a pointer to that register. This time it's a uint64 type because the register is a 64-bit number. Let's also declare a uint64 called done time. That is the current time plus the number of milliseconds we want to count times this 32,768 milliseconds per second divided by 1,000 milliseconds per second. Sorry, 32,768 hertz. That's clocks per second. So that will give us the value that the timer should be at when the time's elapsed. Then we can do a loop and keep reading the current time, and as long as it's less than done time, then we wait. Once we get up to done time, then the timer's finished.